Okay, this presentation will talk about how to build a network, data center. So in our mind, build a data center is just like build a city. So before you develop a city, you need to have a plan. You need to know where is your residential area, business area, where is the office, hospital, university, school, and eventually you need to build a road to connect them together. So when we build data center, it will be the same as you develop or build a city. So you need to plan to put your CPU resources, storage resources, and use network to connect them together. And also, you need some way to connect the new data center and the old data center. So in this presentation, we will talk about when you build this network, you are facing a lot of requirements and challenges. We will present some solutions from Huawei, and with this solution, what kind of services we can provide. Finally, we were talking about the products. So from network perspective, the data center network basically provide dynamic resource allocation functionality, which means the major job from network perspective, the DC network is try to locate the network, the DC resources, which means you build a lot of VPNs based on the requirement. Since this network is direct connect to different CPU and storage with virtualization, so these resources will move around, and your network connect with these resources has to be moved with this kind of migration. So from network side, we were facing a lot of challenges. For example, there's a massive of VMs. For some ISP, probably we need like 100K VMs to support it. We need to support VM migration. And the network has to be non-blocking within the DC. The reason is we don't want the VM, the resource is directly related to the location. That will make your network very hard to manage services. We also need a lot of user groups, tenants, need to support different interfaces in one network, such as layer 2 MAC, IPv4, v6, FC, iSCSI, FIB, different kind of interfaces. Also, as a research, there's different IP has different traffic model. For example, for MapReduce, Hadoop, such kind of storage traffic, we need it's create a new traffic model. It's an incast traffic. We need to support it. We also need to consider the link and the node redundancy, lossless network, and the dynamic and the flexibility and easy to use. So from management perspective on the DC, currently we have commercial software such as VMware Sphere and Microsoft SC 2012. So this kind of DC commercial software basically owned more than 98% of the market. It's widely used on the enterprise company, but not in the ISP carrier and the university. This commercial software can provide, except the basic DC management function, also some fancy functions like billing, like high redundancy, like such kind of functions. Of course, it's not free. It's very expensive. If you see right side, this picture, it tells you you never got save money, operation cost from your virtualization. you just, but on the other side, it's provide more fast service, but not reduce your operation cost if you try to reduce the IT people. We also have OpenStack. It's open source software, so it's widely supported by a lot of companies. Like right now, it's more than 180 companies support this open stack service platform. It's like such as like Rackspace, AT&T, HP, this company. So basic version right now, it can meet the most requirements of the services. Both this software needs the network provide layer 2 or layer 3 capability services in the same time. For campus enterprise network, so we just talking about the DC. If we say DC is kind of humans brings extension, then this brings need more something, sensors or nodes, detectors to feed in this information into this DC. It's like a human. We have eye, we have body, we touch the world, we send this signal to the brain. So in here, if we treat DC as a human's brain, then there are lots of access network and we need to consider. Especially on right now, we have BYOD, so it's a lot of devices is coming in. So on the network side, for the campus and enterprise network, the first important things we need to consider how to secure use these resources, which means there are lots of security issues like AAA verification issues we need to consider. Also with the DC, right now a lot of services, before it's distributed, right now it's moved to DC inside. From the hardware version becomes software version, it's running on the VM. So from here we can see the policy is not just person's profile. It also becomes related to your locations, which means if you log in the network from home, from public, from office, it's where we get different profile. So your profile has a basic part and the dynamic part. So the PDP decision point will be into data center, and the PEP network access part still on the edge nodes. Also, we should notice the security orchestration is changed by different vendor, different solution, and different services. It's always changed. So the challenge for us is you want to build a service-aware network, or you want to build network-aware services. Because the network, the application, actually, the service has a lot, and network only provides the connectivity functions. So what kind of network you want? And if we want to build network-aware services, so which means network should provide some interfaces for these services. That's what we are talking about SDN, which means software-defined network. So the network need to provide some interfaces that the service know what kind of network function network can provide to you. And the service can know, based on my requirements, how can I provide VPN functions and security functions. So once we extended our knowledge, becomes one DC, one campus network becomes globally. So this is a DC's example. They have more than 50 DCs around the world. So they need to use link to network to connect them together. But the problem is right now, the link, the bandwidth between this DC is still very, very expensive. And how do you effectively use this bandwidth between this DC? How can you evenly distribute this traffic on each node, on each link, so then the network can easily handle the burst traffic? That will be a challenge. Which means, from our side, which means traditional SPF algorithm on the routing part probably not fit in this area anymore. We need a new kind of algorithm based on the statistics or based on some kind of traffic mode to adjust this routing rule, this forwarding rule. So here's Huawei's solution for this one. On the DC inside, we could provide a Fed tree topology. So each nodes will becomes pair, use the stacking technology. So for the link redundancy and the node redundancy. So whatever the link is done or the node is done, the network is still working without any problem. So on the inside of DC, the switch will provide very big capacity. To each switch, so right now we could build the world's largest switch. It's around 5 terabits. So we can easily to build several to 100 terabits DC network without any blocking. We use encapsulation technology on the edge nodes, so that could support massive of VM addresses and provide more than 4K user groups or tenants. The network will support DCB protocol, which will let the network lossless. Each switch has a big buffer, so it's for support this incast traffic. This is for how to provide layer 2 network services. So it's easy, like a normal network. You just put some group ID, then network will automatically form a layer 2 network for you. So the user group ID could be from series 40 million. But actually, it depends on your application. It's much more than the 4K VLAN. So for all the nodes, it looks like one hop Ethernet. It's just directly connect to there. You don't need to worry about how to form the network. This is a layer 3 network. So on the same network, if you configure on the port, configure the IP address as normal, the network will automatically form the layer 3 network for you. And one network, physical network, we can support IPv4 and v6 in the same times. Also, if your 2 network, the port already connected to the, already configured as layer 2, you also can connect the layer 3 network. We call it a hybrid network, which means before the network either layer 2 or layer 3. Right now, it's mixed. On the same port, the network will automatically find both network on both port on different physical location, has the same IP address and the same subnet. They will automatically form a layer 2 network. So it's a mixed, it's a hybrid network. It can support IP and IPv4 and v6. So this network also can easily support FC interface and SCSI and IB interfaces. But we need a specific hardware interface for support this one. The reason for that is because we use the encapsulation on the edge nodes. So on the core network, it's just forward the Ethernet. And the different kind of traffic like FC, it's well over the Ethernet, and IB well over the Ethernet, so it will carry over to the destination. So eventually, from customer perspective, when you see the network, it's just one hop network, and the network has an address around there. So it directly connects them. It automatically set up a forwarding table for you. So on the right side, you can see the network. It looks like a big switch. It's just a physical switch. You just configure the edge port, and it's automatically connected for you. Of course, such kind of network, we need to provide a service platform. You can manually to configure it, or use a machine-to-machine interface to automatically configure it. So we will provide the SDN interface, so to support different kind of service platform. So right now, first stage, we will support OpenStack. So it will have directly SDN interface to control your network based on the dynamic service requirement on the OpenStack. So with this solution, one network, physical network, can in the same time support multiple service platforms in the DC. So we suggest customer will set up the whole resources for several service zones. So for some important service zone, we use commercial software such as Microsoft's SC 2012 or VMware because it has a lot of fancy function in there, more reliable. For the normal use, for not important applications, put on another service zone, which managed by OpenStack, so it will be easy to, for the company or for the university, you could reduce the cost. So the network will support, one network physically will support multiple such kind of service platform in the DC. Of course, we have SDN service platform. For one DC, normally you have to have several service zones. The reason is when you talk to Microsoft, they didn't tell you what's the physical limitation. Actually, when you play with it, you can find one service platform normally can handle like 400 physical servers. So physically, if you more than 400 physical servers, you need to have multiple service zones. Of course, there's another reasons like you have security reasons. You want to put your financing department's resource separately managed by one specific service zone. So physically, you want to put them separate. Also, a lot of university or research department, they want to build their own service platform. In this case, your network have to be separated, becomes we call this ISAT to separate the physical network, become several different physical parts. So let the research play with it. So with this network, we can easily provide virtual DC, virtual data center functionality. Also, we can easily handle the VM move around with different VDC. So here is the example of we provide a solution on the DCI for National Bank. So we use DWDM, two dual rings for connecting the different location for the 3 DCs. I'm not sure how many people knows Huawei, but I believe for 2 weeks ago, I think a lot of people know Huawei. because the U.S. government. So I would like to thank U.S. government. Whatever, even they are used the wrong way to attack Huawei, but people will know Huawei. Huawei is the world largest company right now. It depends how do you calculate it. It's first or second largest company. We provide not just except the satellite. We provide every communication devices from terminal to biggest switch in the world. So this is an example. So we provide the DWDM equipments to set up, to connect the different DC. Here is another example with recommendation for the some service provider. So there are 3 DCs. We can provide N times 100 gig with very low cost equipment to connect them together. So each devices with very high port density. We could provide IP and MPS for load balancing and the different services. So I want to emphasize in here, as Huawei, we are not just selling these products. For me, I'm not marketing team. I'm directly come from product line team. What I want to say is we are in the North America, we are more focused on the new technology. We would like to invite all the professors in the university or the researchers in the North America to work together to contribute your talent to this industry. We would like to provide some basic environment, and if you have some idea, you want to implement, you want to do some innovation on the network side, we will work together to try to set up coordinate work together. So products. So on the cloud engine, on the switch, on the loss side, this is right now is the world biggest switch. The fast, the capacity, whatever, from everything you can see, this is the most advanced switch in the world. So each one has line cards. We can have 8 times 10 gig line cards for one port, one line cards, or 40 times 24 ports. This is the highest capacity switch. Maximum right now, as eventually it will reach 360 terabits non-blocking. We can use CSS stacking, so put several switches together to make sure the link and the node redundancy. We support large layer 2 network. Well, there's a lot of arguments about the different layer 2 network. As our Huawei, as a product line, we are open. We would like to work with some expert on this area. We have our virtualization platform, service platform. We can support FCOE. We can support DCB. As a Huawei, we are not just on the one network, one switch side. We also provide a lot of other equipments that include OSN, on the transmission side, on the router side, everything. So on the vertical side, we have public cloud. We can support public cloud, private cloud, and hybrid cloud for university, for government, for ISP, and for every sector. Thanks.